Hi guys, I was thinking about our lecture today, and there's a small part that I left out that I didn't intend to, and it is somewhat esoteric, but it's important nonetheless, and you guys need to know it in case it gets used. So, I need to tell you the story of R hat and theta hat. Well, it's not really much of a story, but here's the idea. We have our theta hat, or we have our, I'm sorry, we draw a circle and we have our acceleration right here, and this is our centripetal acceleration, right? So we create our centripetal acceleration, and that equals v squared over r. However, that's just a magnitude, and because it's just a magnitude, we haven't really identified. We know the direction of the vector, but we haven't given it a name. We haven't created a mathematical operator for it. And so what really happens is the magnitude of our acceleration is the v squared over r. But in order to give our math a direction, the centripetal vector is v squared over r times a negative r hat. And you'll understand the negative in a little bit. It's going to make sense a little bit later. Because r hat is in the direction pointing away from the center. So imagine if you travel, if you move 3 units away from your origin, then that would be a 3 unit in the r hat direction. Well, the centripetal acceleration is towards the origin. And so the center of our circle then is the origin for any kind of polar coordinate that we're dealing with. And so if we're traveling towards the center of it, then it would be negative r hat to come up with that center. And again, this will make more sense, particularly when we start dealing with gravity and in celestial bodies, because the equation for that involves two massive objects, and those massive objects will be attracted to each other, and that attraction will be represented by a negative value in that equation. However, this brings us to, and I skipped a little bit here, at the edges of our, right here where we have our centripetal accelerations, those are, if we have the centripetal accelerations, that means we're moving, and so we're also going to have a velocity for each one of these guys. And that velocity then, if, in real life, we actually can speed up or slow down in a circle. So there is some acceleration that we can have in these particular directions. Okay, so what about the tangential acceleration? Well, the tangential acceleration is just the change in the magnitude of our speed with respect to time. That's going to be the magnitude of our tangential or our perpendicular acceleration. However, it too needs a vector. And r hat needs a partner. Well, if r hat needs a partner, in the previous cases we've talked about I hat and j hat. And I hat and j hat are orthogonal vectors. Well, when we talk about magnitude and direction, we have two different vectors. We have a magnitude, which is in the r hat direction. Okay, so that's r. But then there's another factor involved, the other variable. Instead of x and y, we have r and theta. And that's what happens here. So when you think about what is changing in terms of the vectors, the centripetal acceleration takes care of the change in the r hat direction, in the radial component. But what about in the tangential component? So our perpendicular acceleration is going to equal dv dt with a theta hat. And here's how I like to describe the theta hat. You have we have our r hat, which is pointing away, and then tangential to that. Okay, so we have these two vectors right here, and as we change as we accelerate in one particular direction in the circle, it's going to create a tiny change in our angle. There will be a small change in that angle right there. And as we take the limit as that delta theta, in fact, I should probably, this equals a delta theta. And as we take the limit of this delta theta, as it approaches 0, we no longer have a delta theta, but we have a d theta. So the instantaneous tangential motion creates a d theta, and that d theta is in the, it would then make sense that it is in the theta hat direction. And so the unit vector for a tangent is theta hat. And that's going to help you with your radial and tangential accelerations, perhaps a different way of conceptualizing it, or if you get a magnitude and a direction of your acceleration, that it is such and such r hat direction and such theta hat. This is what theta hat means. Theta hat is the tangential direction. I'm recording this at 11:30. That's why my voice is disappearing. I'll see you guys on Monday.